Hello, everyone, and welcome to Factoring and Applications lesson number 2. So today we're going to talk a little bit more about common factors and look at something called grouping. This is going to be mostly on the first page of the notes. The second page, we are going to look at factoring out fractions. It's a little weird, but I think with some practice, it will be totally awesome. So last lesson, we looked at factoring out a common factor or pulling out a common factor. And sometimes, in certain circumstances, the greatest common factor is going to be a binomial. It's not going to be, for example, we've been factoring out, if we have 9x squared plus 3x, it's not going to be pulling out 3x and then leaving 3x plus 1. In this case, we're factoring out just a monomial, one term. But once we get into some trickier problems, we're going to might be pulling out a binomial. So let's look at a good example of this. So class example 1, number A. You can see we have 4x multiplied by x plus 7 minus 3 multiplied by x plus 7. So we have two terms. We have term 1, subtract term 2, and we're looking at removing the greatest common factor. So in this case, the greatest common factor is the binomial x plus 7. It's that entire term because it's within both of the terms, right? There's two terms and both of them have an x plus 7. So what I can do is I can remove x plus 7, and what I'm left with in the first term is 4x, and in the second term, negative 3. And you can see that here. 4x minus 3 is what's left over when I remove x plus 7. Let's try the next one. 7 multiplied by 3 minus 2y plus 2y multiplied by 3 minus 2y. So you can see both terms contain the binomial 3 minus 2y. So I can remove that as the greatest common factor, 3 minus 2y, and what I'm left with in the original expression is 7 plus 2y. So this is going to seem weird, but it's actually the partial process of decomposition. So we're going to cover this, and then we're going to look at how it applies to factoring larger polynomials. So good skill to have figured out and nailed down before we go on to lesson 3. The next one is 9a multiplied by 4a plus 1 plus 4a plus 1. So you can see both terms have a 4a plus 1. So if I factor that out, what am I left with? Well, in the first term, I'm left with 9a. In the second term, I factored out 4a plus 1 completely, but it can't just disappear, right? We need to have a 1 there, because if we have to be able to get back to this expression by factoring that back through. So if there's a 1 there, then 4a plus 1 multiplied by 1 just gets us 4a plus 1. All right, so it says here, factor the following and write the answer in simplest factored form. So in this case, we have 3y plus 2 multiplied by 5y plus 1, all added to 3y plus 2 multiplied by 4y. So you can see that our common binomial there is 3y plus 2. So I can factor that out, 3y plus 2. And what I'm left with in the original expression is 5y plus 1 plus 4y. And so now we want to simplify, and you can see that within the second brackets we have a 5y and a 4y. So we can add those together. So our final expression is going to be, or our final answer, 3y plus 2. 5y plus 4y is 9y, and we have that plus 1. I will do maybe I'll do D, and then we can do B and C in class. I just don't want to do too many examples here. So we have 20x multiplied by x minus 3 minus 4 multiplied by 3 minus x. Ooh, this one's an interesting one. You can see that this binomial and this binomial, they're not quite the same. But what you can do is we have 3 minus x. If we factor a -1 out, what that does is it changes the signs within the brackets. And now we can rearrange these terms to be positive x minus 3. Hopefully that makes sense. We're just going to change that up a little bit. And then you have to be careful, because what happens is, well, you initially had a -4 out there. Now you're going to multiply by a -1. So it's going to end up changing the sign of that 4, because -4 multiplied by -1 is positive 4. So the trick there was we had to change the order of that 3 minus x. But now that we've done that, we've factored out that negative sign. We've got an x minus 3 and an x minus 3. So we can factor that out of both terms in our expression there, and we're left with 20x plus 4. Not quite done, because if you look at this 20x plus 4, you can actually factor something out of that, right? Both of those terms can be divided by 4. So you could write it, if you want, as x minus 3, and then you can pull a 4 out, and you're left with 5x plus 1. But it's actually better to write it as 4 multiplied by x minus 3, 5x plus 1. The order doesn't really matter, and if you have any coefficients, it's good to put them at the front. It just looks cleaner and tidier. But when you're multiplying things, right, 4 times this term, order doesn't really matter when you're multiplying. Cool. So this is going to be a type of factoring we're going to do, and it falls under decomposition, but again, a good skill to learn. So we are going to do something called factoring by grouping. So you can read this whole thing if you want. I'm just going to jump straight into examples. I think it's a little bit nicer. So what we want to do is we want to group things. So in this case, we have 4 terms in our polynomial. What we can do is we can group them into 2 groups of 2. And now, maybe I'll use a different color for this one, just so we can keep it straight. And now what you want to do is, let's look at the expression in the blue brackets. We have x squared plus 3x. What is the biggest, what can I factor out of that? What is the largest common factor or the greatest common factor? And you can see I can pull an x out of both of those terms, so that I'm left with x plus 3. And now we're going to do the same thing for the expression in the green brackets. I have 6x plus 18. So I can actually pull out a plus 6, and I'm left with x plus 3. And if you're doing this right, you will see that now we have 2 binomials that match. So we can pull them out of this entire term now as the greatest common factor, x plus 3. And what we're left with is x plus 6. X plus 6. Then x plus 6 comes from x plus 6. And now we've got 2 factors. So we factored by grouping, it's called. So again, we can do the same thing. So I'm going to group this into 2 groups of 2. I have 8x squared minus 2x, so I can pull out 2x, and I'm left with 4x minus 1. And in the second one, I can pull out a 3, positive 3. So I'm left with 4x minus 1. And I did it correctly because I can see that those binomials match, right? I have a 4x minus 1 and a 4x minus 1. So I can factor that out as the greatest common factor, and I'm left with 2x plus 3. Fantastic. Let's look at D. I'll do D and I'll do F, and then we'll go from there. So with D, we have, again, we're going to split it into groups, 6a squared minus 9a, and we have 2a plus 3. Actually, what you could do is factor it. You should maybe group it with that negative sign in there. We haven't dealt with one with a negative sign, but it's going to be easier to deal with that negative sign if we group it in. So the first group, we have 6a squared minus 9. We can pull out a 3a, and we're left with 2a minus 3. And the second group, it almost looks like that binomial already, but you notice that the signs are switched, right? It's a negative 2a plus 3, and this one's positive 2a minus 3. So what you can do is factor out negative 1 from it, and if you do that, you're left with positive 2a minus 3. And now you see that you have the same binomial in both terms, so we can factor that out, 2a minus 3, and what you're left with is 3a minus 1. All right, so let's move on to F. F is an interesting one, because if I try to group this right away, you can see that 5 and 18 don't really group that well. You can't really factor out a number out of 5 and 18. And same with the second group, 15 and 6, or negative 15 and negative 6. You can factor out a 3, but it doesn't factor out super well. So what you can do is you can tinker with the order of this if you want to, as long as you keep the signs with it. So for example, if I'm going to move this plus 18y squared, that positive sign has to go with the 18. So I'm going to erase my brackets. I'm going to rewrite this in maybe a bit of a nicer way. 5x squared, and maybe I noticed that 5 and 15 are nice ones to go together. So 5x squared minus 15xy squared. And then I'll do the negative 6x plus 18y squared. So now I've got, within my 4 terms, I've got the 2 terms that are nicest together, right? The 5 and the 15 and the negative 6 and the 18. They seem to go together nicely. So in the first bracket, 5x squared minus 15xy squared, I can pull out 5x, and I'm left with x minus 3y squared. In the second bracket, I have negative 6x plus 18. I can remove a negative 6, and I'm left with positive x minus 3y squared. I know I'm on the right track here because my binomials look the same. Yay! So I can factor that binomial out as the greatest common factor, and it becomes x minus 3y squared, all multiplied by 5 minus 6. Fantastic. All right, so let's flip over. Let's look at factoring out fractions. This is a little bit weird. So I've got a couple of different ways to think about it, and I need you just to figure out which one works best for your brain, and then use that one every time. So you can see here in the example that we have a binomial of 1/2 x squared minus 3x. And a lot of the time we don't want to have fractional coefficients because when it comes to factoring, they're a bit of a pain. So if we can factor a fraction out, then we're left with a polynomial without fractions, and that's easier to factor. So we want to remove 1/2 from this, and it looks like we can take out an x as well. And so they kind of show you the answer here, but I just want to show you how you can get there. So I'm going to rewrite it over here. 1/2 x squared minus 3x. If I know that I'm removing 1/2 out of both terms, you can immediately say, well, I don't know how to remove a 1/2 out of -3, but can you rewrite -3 as a fraction over 2? And we can do that because we know 3 can be written as 6/2x. Now, when you go to remove 1/2 x, you're left with x in the first term. And then when you remove that half out, you're taking out the 2 on the bottom. So if you remove a half from 6/2, or you remove the denominator from 6/2, you're just left with 6. Hopefully that makes sense. It's a little bit weird, I know. The other way to think about it is like this. If you have your 1/2 x squared minus 3x, and I know I want to remove 1/2 x from it, well, the second term, or the first term, sorry, if I remove 1/2 x from 1/2 x squared, I'm left with x. If I remove 1/2 from -3x, I know that x is gone, but I don't know the number that goes there. But I do know that when I go back, if I wanted to expand this, that it has to be 3. So what times a half equals 3? And that is 6, right? 6 times 1/2, or 6 divided by 2, is 3. So basically, you can kind of think of it in reverse. Like if you are going from this to that, then this has to be a 6. So that when you do 1/2 times 6, it goes back to 3. Super weird to think about, but it does get a little bit easier, I think. Let's do some examples and we'll see what happens. Okay, so we have our original binomial of 1/2 x squared plus 4x, and we're going to remove the greatest common factor of 1/3 x squared plus 4x. We're going to remove a 1/3 x. So in the first term, I touched a button. In the first term, I've removed everything except an x. That's the easy one, right? If I take out a 1/3 from here, that's gone. If I take out 1x, I'm just left with x. It's the second term that gets weird. I've pulled the x out, so that x isn't there anymore. And I pulled 1/3 out of 4. So when you factor out a fraction, the value of this actually is going to go up. It's going to get bigger. Because whatever you put here, when divided by 3, has to be 4. And that's going to be 12. Hopefully that made sense. This is really weird, and I've been struggling with ways to explain it. I think I'll just go through a couple of examples, and hopefully it makes sense. The other way you can think of it is you can rewrite your binomial as fractions over 3. So 4, if we want to write 4 as a fraction over 3, it's going to be 12 over 3x. So now, when you remove a 1/3 x, you're left with x plus, well, you took out the 3 and this x, so you're just left with 12. Hopefully that makes sense. Maybe we'll do one more example and then we'll do more in class. I think that'll be easier. So we have a quarter a squared minus 4a. So I want to remove 1/4 a from that. So in the first term, I'm just left with a, which is great. And here, if I remove 1/4 from -4, it's going to become -16. Because now if I factor this back in, I need it to become 4a. So 1/4 a times 16 will reduce to 4a. Hopefully that makes sense. But I feel like it's going to be pretty tricky for some of us. So maybe we'll go over some more examples in class, and I won't keep going through these right now. I think it'll be better in person when we can work through some of the issues together. Cool. Thanks for watching. I'll see you next time.